Good evening, everyone. Welcome to today's second technical section and third general meeting of the Nigerian Society of Engineers, Proposed Germany branch. I welcome you all to a wonderful section today, and I'm looking forward to a very productive discussion. I'm sure we had a very lovely discussion the last time we met, and I'm hopefully we have our speaker already in the room, and I'm sure we came with our questions. So not to cut a long story short, I would be handing over to Engineer Adeleye for the opening remarks. Thank you.
Yeah, thank you, Engineer Oluwatomisi. Good evening, everyone. You are all welcome wherever you are joining us from Nigeria, Germany, from other parts of Africa, South Africa. You are warmly welcome to our third technical session. We are very, very happy to have you all here this evening. Especially, we're joining millions of Nigerians to celebrate Democracy Day today in Nigeria. Our prayers are with our home country that all of the contributions that we are all trying to put together will be towards the development of the country to build a stronger nation for us, and that we have, all of the, things that we are getting to learn, the opportunities that we are getting to also uh, meet also here in the foreign land will be used for the betterment of Nigeria. In light of this, and the current happenings all over the world, we have someone, that we know that we just as we are all outside of the country, especially here in Germany, and we are looking at how we can impact our home country. And so, even presently, what is happening in South Africa, in Ghana, in Togo, that we all see online concerning Nigerians, we are looking at how we can impact Nigeria from all of the knowledge that we are all acquiring in our different fields and also in our different professions. So you are welcome to this technical session. Um, I also want to quickly say that for those of us that are also here in the meeting, I have shared some links in the group. We've had some information, especially when it comes to project management, and also when it comes to using artificial intelligence in machine and also in equipment constructions. There's a white paper that was released of recent. We shared a link to our Google Drive that you can also take a look at it. It's in German, but you can definitely translate it into English, and then you get so that you can get this information that we are sharing. Also, there is a program coming up in Nigeria, 14 to 15 July 2026. It's called Solar and Storage Exhibition in Nigeria. Please take out time if you're in Nigeria to be part of this program as well. It's also in August. We have a summer event that is coming up on the 1st of August. We're having a get together. We all have to come together, not just seeing ourselves all the time online. We have a physical meeting in Frankfurt on the 1st of August of this year. This is the address shared on the screen for us. This flyer is also available in our WhatsApp group. Um, for the benefit of some of us that are also here, if you have companies, if you have side businesses that you are also running, please feel free to share with us so that we can also spotlight your endeavors for all the community to be to have a glimpse of what we are doing. Digital Infraco, for example, is one of our past chairman in Manchester. This is his company, and they are into enterprise connectivity and digital infrastructure there in the UK. This is my own endeavor here in Germany. We're looking at helping companies, private institutions, government institutions to reduce energy consumption, to improve their energy efficiency and sufficiency, and also making sure that systems generally are sustainable in their entirety. We also have this endeavor from one of our member, Engineer Ferdinand, is looking into Afro Science magazine. Please reach out to him if you have any special paper, any special article that you feel is for the development of engineers of science in Africa. Feel free to contact him so that he could also get it in his review and magazine that is also putting together. So before we go ahead and go to a brief bio of our presenter for today, we have someone online who is our patron. We cannot afford to see him online and not recognize him. That is in the person of Engineer Ademola Isaac Olorunfemi, FNSC, past president of NSE, is here online. We just wanted to say a few words to us before we continue, sir.
Yeah, thank you very much. It's my honor. I'm grateful for privilege. I want to welcome everyone. I must commend you the way you're coming up. There is no doubt you're going to give everyone, every branch, home and away, a good one for their money. I'm excited to be part of this good sound beginning. Thank you very much.
Thank you so much, sir. So I'll hand over to you, Engineer Oluwatosin, to continue. Thank you. You're muted if you can.
I was trying to find my mute button. Yeah, so I have the privilege this evening of welcoming our guest, Engineer Abiola Kehinde. So I'll be reading a brief citation of Engineer Abiola Kehinde. Engineer Abiola Kehinde is a Nigerian-born, accomplished professional specializing in renewable energy, waste to energy, circular economy, sustainable green building, and innovation system analysis. His passion for renewable energy, sustainability, green building, and waste to energy has led to the development of influential systems and policy instruments benefiting public and private institutions across multiple nations. Engineer Kehinde boasts an impressive educational background, holding a BSc in Mechanical Engineering from Olabisi Onabanjo University, a master's degree in Mechanical Engineering from Stellenbosch University, and a PhD in Chemical Engineering from the University of Cape Town, alongside advanced certificate. Engineer Kehinde received a Pioneer Award from the NIMechE National Student Forum in Nigeria in 2013 and a Service Award as the president of Sustainable Development Goals CDS Group during his NYC. He has worked as a building service engineer in Nigeria, where he gained valuable experience in the building sector. He has also worked as a researcher at the University of Western Cape and Cape Peninsula University of Technology in South Africa. Engineer Kehinde is also a guest researcher at the Fossil Exit Research Group, Europa Universität Flensburg, Germany. This is an interdisciplinary research group investigating the transition from fossil fuel to 100% renewable energy. Engineer Kehinde is the current chairman of the Mechanical Engineering Alumni of the Olabisi Onabanjo University. He's also a South African representative for the Biogas Unite organization, an organization that seeks to address biogas failure across Africa. Engineer Abiola is currently a research analyst at the University of Cape Town, and his research is assessing the barriers influencing the contribution of renewable energy to South Africa's energy, climate, and sustainability transition. He has published several articles in reputable journals and presented his research works at various local and international conferences. He's passionate about contributing to the development of renewable energy solutions, waste and management, and promoting sustainability in Africa. Join me today in welcoming Engineer Abiola Kehinde to the platform. Engineer Abiola Kehinde, yeah, over to you, sir.
Thank you so much for having me. Good evening, everyone. I'm so happy to be here. I want to quickly to share my screen so that we can I can start the presentation. And also to thank Engineer Edward Thompson. Thank you for the introduction. And also I want to thank the chairman and also all the planning committee for the opportunity given to me to be here to present to the whole community of Nigerian Society of Engineers in Germany and all over the world present. Today, the topic I will be discussing is basically on integrating renewable energy at scale, insight from Germany energy transitions for Nigeria's power systems development. Yeah, today we will be looking at some just a brief things that we'll be discussing today. The context of what we are going to be looking is not going to be more of maybe engineering theories or probably how to build solar because I know we are all engineers and also we are familiar with all these technicalities about renewable energy. But we are going to be looking more of, about grid stability in terms of renewable energy, looking at the regulatory framework and also infrastructure investment, and also in terms of decentralized solutions. And one of the things we are discussing, I mean, is looking at how we can better solve the Nigerian situation regarding the power systems, who is actually deficit at the moment, and how we can actually integrate renewable energy into our systems, in our energy power systems in Nigeria. And then the case study we are looking at is the Germany, as I said from the topic, being the fact that, I mean, currently they are generating, I'm sure everyone who's in Germany, some people are in Germany anyway, generate over 50%, they are generating over 50% renewable energy and exporting that into the agri. And then also we want to look at, I mean, what are the actionable engineering strategies that we can benefit, I mean, extract from Germany case study, and then we can apply that to Nigerian systems, especially the grid systems. Okay, I mean, looking at the Nigerian power crisis in Nigeria, power crisis in Nigeria, we all, especially, is not a new thing to us that, I mean, we have challenge regarding to electricity, regarding to energy systems, energy in general overall in Nigeria. And then just to a little bit, just to run through some of these challenges, we all familiar that, you know, barely some, especially many Nigerians could not afford to, I mean, to just this basic need, electricity. You know, they could not afford to have 24 hours electricity. And then these situations are real because, I mean, looking at the installed capacity, uh, we have about 13,000 megawatts of installed capacity, and that is quite small if we have to look at the number of people that this capacity have to serve, which is about, you know, more than 200,000 million people in Nigeria, which is quite a lot. And then if you have to look at this install, I was just looking at that amount compared to the amount in South Africa here. I'm not talking about Germany. I mean, South Africa at the moment is actually has about 48,521 megawatts being installed. And then, so looking at that, the distance is quite far. So then we have a lot to do. But I mean, these are situations, these are current situations. And then looking at that, despite that we have that installed, how much are we operating? How much are we producing? It's about 4,000, 4 to 5,000. And even this 4 to 5,000, there's so many cases I hear about, I mean, grid being collapsed and so on and so forth. So, and if I have to look at that compared to also to, I mean, Germany has more than more than 30,000 megawatts, you know, operating capacity. Even in South Africa here, we actually produce about, I know, about 32,000 megawatts in operating capacity. So Nigerian situation is quite real and also very enormous to everyone. So looking at that, it's not that there's no technology, there's technology in place, and then even the one that is even being installed is actually producing energy. But why is this I mean, looking at that, if you have to look at it, we have 13 megawatt being installed, but the one that is actually operating is about 4,000. So we have the issue of grid, grid infrastructure. So our grid infrastructures at the moment, that is why we said about at the moment is not good. That is the word I can give because at the moment sometimes I do hear grid collapse, blackout, and so many times. I mean, that is our current situation. So our grid is fragile. It's not good at all, and it cannot actually be able to transmit this kind of energy that we generate. Even the energy that we have, there's a lot of losses been going on. I mean, when this grid is actually being transmitting this kind of power to households. So this infrastructure is quite weak, which needs to be replaced. And then we can see that, and that is why from the graph, from the pictures from the graph I showed, which is actually from NERC this year, we can see that despite that the amount that they are actually operating on, you can see that before this amount, they could not even actually reach to up to 30 megawatts. They could not because the amount that we are actually before the thing actually during they could not suppress the peak. So we are actually operating below what we're supposed to. So and we can see from the economic perspective because of this situation, people have to rely on, diesel generators. These are quite familiar to every one of us. And then at this moment, also, when we look at the energy mix, also, we can see that most of these our mix in Nigeria, sorry, is actually being dominated by gas-fired thermal plants and also hydro. These are the big major aspects that big major plants that we use to generate electricity, generate energy power in Nigeria. So these are the current situations. Then I move to the next slide, which is also looking at the current situation of Germany, because we are using Germany as a case study. So looking at the current situation of the Germany, because we are using it as a blueprint, as a template for us to be able to see how we can better improve our own energy systems in Nigeria because we are talking about energy transitions. And then if we are talking about energy transition, we know that transition is about from one fossil fuel. People are talking about fossil fuel to or coal to renewable energy. So, but just for us to be able to have this kind of understanding, I mean, Germany transition does not just start just in a sequence of time. I mean, so they have been using coal and then also nuclear to develop their to develop their grid system. And the major thing, I mean, affecting or the major thing about when we are talking about energy, especially electricity, is the grid infrastructure. So, and we can see that before Germany actually talking about energy transition, they have actually been using coal, nuclear, this fossil fuel to develop their central grid system. And then these are one of the things that I will still talk about later on, which is I just want to stop from here. And then from there, after the grid system, have been actually well developed, and then the issue of coal, this fossil fuel actually spring forth for them to actually transit away from the fossil fuel to decarbonize economy, to decentralize energy system, which is the renewable energy. And then, as I said before, currently now, as we are transiting away from fossil fuel, more than half of German electricity now is being produced by renewable energy. And this is quite success. This is quite awesome. And also, most of these renewable energy are actually coming from onshore, offshore wind energy power plants, and also utility scale solar PV. And then we have biomass. And then I'm so quite amazing when I visited Germany not quite long last year. And then also to see all this infrastructure in place in various places. And then that is quite massive, especially the biomass plant, the solar PV, and also the wind. It's quite amazing. Even some university campus has various kind of wind turbine. I mean, being in place. That's quite a big infrastructure, which a good lesson that we are going to also to discuss today. So one of the things that we need to learn, I mean, key lessons from this kind of transition that Germany did is that, one of the things is that there is a political will regarding to transition. There is a political will regarding to building infrastructure, energy infrastructure for Germany. So, which actually is also something that we must learn. And also there is a clear engineering standard. And I think of recently I'm also hearing about standard in Nigeria. But I mean, before people are just doing things the way they like, and also market incentive. These are three things that actually very important if we want to have a very good uh, um, power sectors working effectively in Nigeria. So these are the key lessons that I mean we can both learn from this transition. They have a very good political will, which actually make them to be able to be solid, to have a very good infrastructure in energy sectors, in power sectors, and also in terms of the standard, they have a very, they have a lot of scholars, a lot of engineers, and also a stakeholders which were able to come together to have a very clean and clear standards that they can work with to make sure that yes, they have a very good infrastructure for their energy systems. And also, not just only that, because if we have that and there's no market, like what I'm saying now, there's technology, but technology cannot just market itself. So they also create an incentive, which is which is also something that we are going to also to learn. So moving from there, we want to look at what this key insights and see what are the things that actually different. I know we want to compare all these things together. I mean, looking at what Germany has and their current status, and also looking at the Nigeria, we can see when we talk about transition, I mean, this renewable energy, we can see that in terms of the solar irradiance, I mean, the amount of solar that is actually coming to Germany, it's quite not that, no, it's quite not that much compared to Nigeria. Nigeria has an excellent one and generate, about 1,800 to 2,500 kilowatt per hour meter square. And that's quite great. What are we using that? I mean, we should tap into that and use something and do something with that. I mean, when it comes to the grid sectors, I mean, we know definitely our grid is nowhere to be found. Something has to be done to that because without the grid itself, without that infrastructure of that, I mean, there's a well planned infrastructure, is well adequate grid infrastructure, then definitely, even if we have the technology, if we have the power plant that is producing energy, then it's still something that will not produce yield a good result. So, and this is one of the things that the German people have actually been able to do. So they have actually have a well-connected grid infrastructure, that is stable and they can be able to manage effectively. So which we don't have. So when it comes to the generation type also, now they do not just leave the central generating power plant. They actually still continue to to operate the central energy systems. And also they still have decentralized one, both centralized and also decentralized one. There is a way they manage both the two together, which actually they are grid system because they have a very well adequate sophisticated grid infrastructure. They can able to manage both the centralized power plant systems, renewable energy, and decentralized one. It's also quite amazing that even some biogas also exports to the grid. When I traveled down to Germany last year, I was able to see some of these infrastructures in place. So, but when we look at our own situation in Nigeria, we can see that most of the things that we have is basically a thermal energy systems, and then the backup is actually basically on diesel. And then this even this thermal system, We don't have the grid, the one that is producing. We don't have the grid, adequate grid infrastructure to accommodate that. So if we don't have that grid infrastructure to accommodate that, then if we are also now talking about energy transition, we want to bring into, renewable energy, decentralized one, or even centralized one, then we can know that we are actually setting for actually total, if there's already a total showdown, then compressing, bringing more infrastructures that does not, that that have a very how do I put it now? Bringing another technology that can create more problems for the grid infrastructure, the grid system that we have, then it's going to be a total collapse. So, but when we look at the financing part, we can see that people can be able to invest in Germany because of this adequate investment they've already made, this adequate structures they have created for themselves. So, we have actually a low risk and also low interest capital because their government create this environment for them so that people can actually invest. But when we look at our own history, I'm sure everybody, even the investors, know the situation. So it's actually a risk, for you to say you want to go in, you want to venture into renewable energy, you want to actually partner with government and say, okay, I want to build, because if you even build the technology, you still have to sell your technology. So you still have to sell the energy you are producing. These are situations. So the capital constraint, you cannot be, but there's no bank that wants to borrow because they know that if you borrow, how are you going to pay us back? So these are situations that are actually very rampant in Nigeria. So looking at this comparative analysis, I was able to pick one or two, 3 points that are key insights that we can both learn and also see how we can actually work on that. So the first insight is about the grid flexibility and management, and that's one of the things, one of the biggest issues, one of the biggest things that, if we want to have adequate infrastructure or probably stable electricity in Nigeria, is for us to have this grid flexibilities and management and adequate infrastructure for grid. The current grid, I don't think there must be a way of, how to do the overhauling of our own grid systems. So we can see that when it comes to grid flexibility and management, there's a way that Germany has adequate weather forecasting models that can predict the way the weather behaves, the solar, the winds, and all accurately. Nigeria does not have that kind. We have not gotten to that aspect. So, but we can get there. We can get there. This started from somewhere. So we need those things. If we have to talk about energy transition, we want to transit to renewable energy. We want to also to add renewable energy to our grid system. So we have to look at, how to manage, the flexibility of the grid because depending on how much the energy that is producing that we are inputting, and don't forget we also have our own central systems, the Taman and also other ones that are also producing. Although it is not enough, but they are also producing. So they also are also, they also create problem for the grid itself. So we must see how this thing can be both managed and also that can accommodate the flexibility of the renewable energy transition that we are talking about. And also another thing is German also has make use of battery storage and smart inverter, for them to stabilize the grid system. And then these are things that we must learn also, as Nigerians. I mean, for us to be able to have adequate system that is functioning, we must actually, invest in that kind of aspect of battery storage and then also smart inverters. These are very important because the issue of grid collapses every moment and every down and forth will not actually help us for us to move forward or to actually make a good for us to get a good investment or let our economy to continue to improve. So in terms of this Nigeria thing, we need to, I just put it there that we need to implement, in terms of automated supervisor control and data acquisition. We need aspects of how to both invest in these aspects of data control, data acquisition systems where people can actually involve in predicting, come up with a lot of models, a lot of technology that can actually predicting systems, if we have those infrastructures, I know, that can actually support the our grid infrastructure, we see that it will definitely be able to manage effectively and also to be able to accumulate the flexibility of what we are talking about, that we want to transit, we want to actually have renewable energy to actually come into our energy system in Nigeria. And one of the things is uh, the action things, one of the challenges is that sometimes our engineers in Nigeria, most of people does not have, or probably they have not managed, renewable energy systems before. Some people are now just upgrading themselves. Some people actually know, I'm not saying everyone, but people, people actually just, their eyes are just opening so that, the earlier the better that we start actually upgrading ourselves, because these are not their profession before, but because this renewable energy just comes into us, then we must actually upgrade ourselves and then make sure that we fix it. So, but this is not just about fixing it, it's about actually understanding how these systems work. So if we understand, then we can both manage. So these are situations that are very, very important. So another key insight is decentralization and embedded generation. This one is also very important. So what did I mean by this one? We know that sometimes I know a lot of people in Nigeria currently they have the solar systems. People are generating solar systems because government also allows some amount of megawatts to be generated individually. So we can see that in the case of Germany has create an enabling environment for individual people to actually export their excess energy being produced within themselves to their grid. Because of the grid, they have like I said, their grid can be actually, they have a sophisticated grid that can take the flexibility of this situation, of this decentralized system. So in our own case, we don't have this thing. So if we continue to generate electricity, the only challenge is that people will be using the challenge, but they may not be able to profit from them. And this is also a case of scenario in South Africa here, that a lot of people individually also profit. I mean, they sell their excess renewable energy they produce from their solar rooftop, and then they export it to the grid, because also South Africa grid can able to assimilate some assimilate some not that 100% good at their grid system, but it's to some extent they can still be able to accommodate this kind of flexibility. Another thing is they also make sure that the small scale producers also invested by historical feed-in tariffs. These are very common to us. I mean, we all know that. I mean, one thing that helped Germany to for them to be able to succeed in renewable energy is because of this feed-in tariff. So these feed-in tariff policies really help them, and which makes a lot of people to tapping into that policy, and then it actually catalyze and or make sure that the whole system of their energy system actually turn around, and then they were able to transit successfully, moving away from fossil fuel. So when we come to our own cluster, what can we learn from that aspect? You know, it is to me, based my own. We need to focus more on mini grid and embedded generation. But to me, we must not think of exporting those mini grids to the grid, mini grid to the grid to our central grid, because at the moment our central grid is not effective, is not efficient. But we can actually have that mini grid being supplied. Probably we can have it near industrial areas, or where major companies within the companies, and then supply those energies to them. But exporting the excess to the grid at the moment is not going to be sufficient. And I know that at the moment also, I mean, a lot of people also, because I mean, based on the current policy in Nigeria, has created that each state, because each state can also generate electricity, which I mean, Lagos State are also doing that now. And then also Ogun State, I heard about Ogun State also going into generating their own electricity. From Lagos State, I stated here that I mean, in terms of the GIM 6 megawatt clean energy plan is on their target. for them to be able to move away from diesel generation and then for them to be able to use a gas and solar hybrid. These are good initiatives, but these things must actually be able to actually fit in that it is not just only just a maybe just a set of people. Because now, if we are talking, okay, Lagos State is actually going to produce gigawatt. Who are they selling this gigawatt? Who are they going to export it? Because for them to be able, at the moment, for them to be able to, meet the need of the people, then they have to export this kind of power to our poor grid, to our poor infrastructure grid. So how are we going to do that? So then these are situations that we must look at how we can both effectively tackle the issue of our grid infrastructure, which is the major point that I've been talking before. And then we can see one of the from the graph before I move on, we can see that if we moving away from fossil fuel to renewable energy, we definitely is actually a very profitable one. It's good. I'm an advocate of renewable energy. So when we look at it, if we have adequate infrastructure, I'm not sure that I'm still trying to look at it, but I've not seen whether there is any policy that can actually empower the states to develop their own grid, probably to bypass the national grid and also create a grid within the state. That would have been a very great initiative if something like that happened. Because if we can have a decentralized renewable energy system, maybe each state have decentralized, we can see that it is possible. Maybe within like the graph shows, that is a report that show about the financial viability of decentralized renewable energy. That if we can have a renewable energy that is actually based on actual grid like that has a good grid infrastructure, especially being in place in Nigeria, it's possible to to have a payback. I mean, to make investments and then within 6 to 7 years. And this is a very good initiative. But the issue is, do we have adequate grid infrastructure in place at the moment? The answer is no. So another key insight I want to talk about is the policy. And this policy is also very important because most of these things, another thing is to have the technology. There's technology in place. There is so many things, we have so many ways of technology that we can use to generate electricity. But if there is no adequate policy or regulation or market incentive in place, then it will be difficult for us to be able to maneuver to get this kind of our energy in place in good shape. So we can see that in the case of Germany here, like I said, they have a policy they call Renewable Energy Source Act, which actually guarantees grid priority for green power. So with kind of policy, it gives the people in the country for them to invest in renewable energy because they know that yes, government is actually backing them. And also, like one of the schemes, I mean, in terms of the market intensive, in terms of market framework, like the feed-in tariff, they actually do that. They sometimes they auction, some schemes out for them to be able to, for people to be able to actually, buy the idea of, going into renewable energy. And these are something that are not new to every one of us, which are something real and currently still happening in Germany. So what should we do as Nigerians? I said Nigerian applications. We need to see how, though we have some policies are in place, which actually give us, like I said, give us things to generate electricity, but we need to optimize that electricity act, that 2023 electricity act. A lot of things have been said that I've read through, but there's still some lapses that need to be fashioned. So if we can actually, operationalize that thing, I think if there is a way our policymakers can actually look into that aspect. I mean, how restructure the policy and this act very well. Then it will create a room environment for even the investors from outside to be able to adequately have the boldness to come and invest. And even they can invest in our grid infrastructures because that's one of the major things that needs to be done urgently at the moment I can say. So there is a way, and another point for the market to be sell is that government still needs to create a policy that will actually create a cost effective. I mean, that can give people, a rest of mind that, okay, if I invest and go, there's a way I'll get my money. There won't be more of tax. If I want to come and do business, then tax will not kill me and take me away. So these are things that should be a subsidy, though as much as I don't really believe in subsidy, so, but that should be subsidy because there's a lot of things going on when we talk about subsidy. But to me, there should be somehow a little bit subsidy that can actually help to catalyze the investment or the turning around of the energy sectors in Nigeria. So, looking at the technical barriers to these implementations, what are the engineering bottlenecks? The first thing is the transmission capacity. Actually, the current, this one cannot absorb the intermittent, so like our current grid cannot even, if we try to, most of the grids that the RIA is actually doing is basically in rural and it's actually decentralized, that is not actually, that is not connected to our national grid. So our national grid at the moment cannot accommodate renewable energy. So when we are talking about transition, so our transition does not actually go into developing renewable energy power plant and exporting it into our grid. We cannot have energy mix currently in Nigeria. If we do have, definitely it's going to kill the whole. The little we are still getting is going to be actually we still talk about total blackout, but I don't think that I don't know any other word for total blackout. So another thing is that still also needs to talk about the gas to power coordination. I still believe in gas. There's a lot that Nigeria currently produces a lot of gas. Sometimes they clear those gas, so we can still have gas as a backup. Fine, we can talk about gas is not a renewable energy, but I mean we still need this great infrastructure to be developed. We need a solid infrastructure, so we can still, despite that we are still talking about transition. So once we have our grid, we can use this non-renewable energy to develop this kind of skill because other developed countries also they have used this to develop their energy system. So we also can use this in Africa, not even in Nigeria alone. And then we can talk about transiting away from this fossil fuel and to renewable energy. So another point I talk about is distribution losses. I mean, there's no way the grid, if the grid is not okay, definitely there will be losses here and there. So and another situation and is also happening is the shortage of local power system engineers trained in this. Most of the people, I can see that now currently, before it was quite a lot of serious gap. But I mean, a lot are already happening because I'm very conversant with a lot of people working in the renewable energy. I mean, solar, so to speak specifically. But I mean, we need more than just solar. We need wind. In the north side, there's a lot of wind to do happen. We need more farmers, not just only solar PV, but more of sophisticated. We need solar thermal energy in Nigeria. We need a lot of things that can actually help us to have that can help us to transit away and then have a good energy transition and also have a good stable energy systems. So moving from that, I propose this roadmap. This one should be just a short, a medium term that we can actually work with. I said if we have to do, we can actually, because of this current situation, I think also RIA is also doing that. We can deploy a utility solar in the north, pair with agricultural mini grid. I mean, RIA is also, I can see that they move a little bit to local community to develop. But I mean, not just only develop, but there should be a way of market in a way that, because I see that most of those power plants are just grant funded projects. And then I look at it in the next 5 or 6 years. What is going to happen to the plant? There any maintenance? How are they going to get the money? So these are things. So if we are deploying utility scale, I mean solar power plant to any nearby, maybe in the north because they have a very solar area, then there must be adequate infrastructures, decentralized systems that will be taking place, and also in terms of the market and the management of it. So I said within the 3 years, there should be something like that. And I know, I mean, the government are doing something like that. But I mean, privately also, we can also develop something. I know there's some also company that's actually working like that working with some estates in Lagos, which is something that's also very good. And the second phase, I said there should be a regional I mean, grid tied storage solution to stabilize the weak node. I mean, that's why I'm still trying to find out if there is any way in our policy that actually empowered, the states to actually have a storage system or probably to build grid. Because if we do have that, it can help. Maybe there's a way we can, like the government can actually accumulate, maybe individual excess energy produced from solar top or some other renewable energy that they can actually store and then be able to provide solution when needed to people. That would be very great initiative. So I propose that if kind of thing can be implemented, that would be good. And also, I propose that not just only implemented within the regional, so also it should go across the Western Africa. Because I know Nigeria also supplies some electricity to other West African communities. So these things is just a short and urgent things that we need to do. So now, what are the roles? Engineers in diaspora. What can we do? The first thing I mentioned here is technology transfer. We need to see, we have seen a lot how things have been done, especially in Germany. Most of us are in Germany, most of us are in various places in diaspora. We need to see how we can actually equip people, build workshop, and also we can intensify this kind of train people. And also, if it is possible for us, we can join partners with the engineering firm, these people, and then also come to Nigeria to bid for projects. And if we can have bid for projects like especially these grid infrastructures, we have adequate grid infrastructures. I believe things will be more normal. And also, not also only because for us to actually have this grid infrastructure, there must be adequate policy. So we need people also, and I always stress this in wherever I go that we need people, especially because I see that every country I've gone into, there is a kind of, especially the young people, talking about the policy making. They are very well conservative with policy, their country policy. So we need most of us are in diaspora. We are even even me that I'm talking. I'm very well grounded about the policy of South Africa than even my country. So we need to be well grounded about our policy. We need to advocate. We need people, consultants that will actually be closer to the government, advising government, giving government advice. I know they have a lot of people that surround them, but not just only them. They need external people. They need fresh ideas, fresh people, especially we in diaspora, because we see far than those people are in Nigeria. So in conclusion, Nigeria's situation, energy crisis is solvable. We can adopt the approach the German use. One of the approaches that they actually make sure that they build their grid infrastructure, and then they use the fossil fuel to build those infrastructures. We also can use oil and gas. We have oil and gas in place. We find people are talking about energy transition. I believe in energy transition, but let's have this grid infrastructure in place. Let's have these systems in place. Then we can now continue to, because if you don't have this system, then we're talking about transition. Then we are creating problems. We are creating more problems for ourselves. So another thing is we have opportunities. There's opportunities there. We generate more solar radiance, than any other European countries. Than especially the Europe. So we have opportunities. We in diaspora, we can actually come up with an idea. Whether we want to take the policy part, we want to take the technology, the technical part, or we want to take the market part. We have ideas. We can come up with solutions. And I said actions. Engineers must drive the technical standards to transit from design to execution. Not just to design, not just to come up with ideas, but we must also come to implementation actions. So if we are in diaspora, we are here now, we must take action. What are the actions? We know that we have the challenges of the problem of electricity. It still continues. It has not been solved yet. What are the things that so we must take actions as engineers, and these are the things we must do. Thank you. Thank you. I don't know if we have over to you, Sam. Am I audible?
Yes, you are.
Yes.
Yeah. Yes, sir.
Our uncle, you are muted.
Yes,
You can
I
speak.
can hear you. So I'll be taking over from here. Thank you very much, Engineer Abiola Kehinde. That was a very wonderful section. And I can see that we already pumped up. People already have questions in the chat. So we will be moving straight to the questions and answer segment. We have two questions in the chat already. If you have any question, if you want to ask any question to Engineer Kehinde, you can please raise your hand, indicate by raising up your hand. There's a raise button a raise hand button just above your screen, so you can ask your questions. But I will be taking the questions from the chat first. So please, and also anyone who is asking questions, please let's be direct and let's be concise so that we can manage our time properly. So the first question, Engineer Abiola Kehinde, is what is wrong with Nigerian grid that makes people say it is poor? Do you want me to read all the questions out first, or you would like to answer them
Okay, I think
simultaneously?
I can. Yeah, I think I can take them one by one.
Okay. So the first question from Daberechi Agu is, what is wrong with Nigerian grid that makes people say it is poor?
Yeah, thank you very much. That's a very good question. One of the things that the reason why we said it is poor is because when these grid infrastructures were built, was basically on the amount of the capacity it can take during that time. I mean, in the 90s. So, and then the amount of businesses or the number of people or the uh, number of people that actually use electricity were not that much compared to what we have now. So the infrastructure that was being built that time, I mean, in terms of this, what did I mean by infrastructure is like, the power lines and all those things that they built that time cannot accommodate. I mean, those things are old, and then they need maintenance. They need maintenance. They need, a lot of technology has advanced that can take more energy, that can actually distribute energy without not losing energy. So these are the things. The reason why we are saying that Nigerian grid is poor, because these infrastructures are old infrastructures and no one is maintaining it. There is no improvement on it, and then even if we have to generate electricity now, this grid cannot distribute effectively because there will be loss. So this is the reason why we said the grid infrastructure is poor, because technology is there. People can, if I have money now, I can say I want to build power plant in Nigeria, but still yet there's still a problem, because if I'm producing, maybe for example, I'm producing 50 megawatts, but at the same time, when I'm sending 50 megawatt out, people at the end of the day, by the time it's going through the grid, maybe there will be a loss of, probably out of 50, there will be a loss of 40. So it's not cost. So these are situations. It's not going to be in terms of the business wise. The people that is producing electricity energy will not be able to profit more. So these are losses that is actually happening. So we need to improve. We need to improve our infrastructures. We need to upgrade it to more sophisticated aspect that can actually contain those renewable energy. Because now at the moment it's just only the thermal energy power plant that we have an hydro, which is still giving us more problems. So if we have to have the intermittent renewable energy, and then the flexibility, the instability of the grid will also create more problems. Yeah.
Okay, thank you very much. The second question, I would add the second and third question. Does centralized grid mean that mini grids should not be connected to the national grid? And is there any advantage of having a centralized grid?
Okay. Centralized grid. By centralized grid is that it doesn't mean that, like, it means that you have a separate power plant apart from the national power plant. But what I'm trying to say is the centralized one can actually be connected to the grid. Mostly, especially let me just use a case study in South Africa here. there's a lot of private enterprises that actually have a private centralized renewable energy, and then they sell those renewable because there is a well infrastructures and also there is a market incentives available here. So they produce those energy and then they sell it to the government. So which means that if they are selling it to the government, they use it and also they sell excesses to the government. So if you are selling it to the government, so you are actually going to connect it to their grid, to the national grid, the central grid. So this is we need that we can have the central current system, the grid system that we have, if anyone has to connect, if anyone has to send any electricity, renewable energy electricity to the grid, then it's going to create more problem, number one, and also it's not going to be profitable for whosoever that is venturing into that. Yeah. But it can be connected. So it doesn't mean that it cannot be connected, it can be connected, and also it can stand alone. It can stand alone, it's both ways. Yeah. Thank you.
Very much. I'll quickly take the next question and then we take the person who is raising up his hand. So, Samuel, as in just a minute, we'll get to you very soon. The next question is from Okwa Adekole. He's mentioning if weak grid is the bottleneck in Nigeria, why keep investing in generation? Case in point,
Mm,
federal
mm,
government
mm,
recently announced a $20 million, 20 megawatts solar project in Kogi State. Why not deploy that investment into grid infrastructure instead?
mm. Very good question. Very good question. These are situations that actually surrounding the energy system. I mean, misplaced priority. I mean, these things are not just eating. Everybody is well known that we have great infrastructure problem. So the issue of misplaced priority is what actually also affecting Nigeria because now, because of what they are going to profit, I mean, I'm talking about it politically now, because of, they know that because if you build more infrastructures, if you build maybe more power plants, there's some money they will get from it. So they don't want to solve the issue of the problem that actually, because they know that even if at the end of the day they build that power plant, the issue of the grid that will even distribute the power plant is still there. So it's still the same result. So my own situation is we need more people, especially diaspora or probably more engineers in this regard to advocate and also to push in this regard to the government that see this is the problem. And then most times even the government knows about this thing. They have an expert. They have a lot of people, at least I know some people that are very close to them and they know, but it's just because they decided that this is what we want to do because they are going to have their own, maybe their own gain or their own profit from this side, and then they let what they're supposed to
Okay, thank you very much for that answer. I think Daberechi asked a question sequel to that. He was asking, so is the grid, if we understand from what you've mentioned so far, the grid is obsolete, it cannot support the energy system. Does it mean that we need a grid expansion, in your own opinion?
Yes, we need grid expansion. Yeah, that is the most important thing that we must do if we actually want to solve the issue of energy crisis in Nigeria. So we need good expansion, and also there's a question that talk about do we still need like what is the advantage of having centralized grid system? To me, having centralized grid system is still good because you need you need a centralized system to be managed. You need someone to manage the whole system. You will still need people because if you have decentralized, I still need a coordination with this centralized system. So you need someone to still manage the whole system together. So if we have a central system, even if we have decentralized power plant systems, we have decentralized system that generates electricity. There should be a centralized system that actually manage those other systems. Fine, they can generate their system, they can sell their output, but there should be a centralized grid that can actually be effective and manage that can accommodate those excesses, those decentralized ones, so that yes, it can be adequate when there is a shortage in one way or the other, then it can benefit to complement each other. So we need it because every Nigerian, not all Nigerians that can actually produce, that can buy solar power plants. Even if you can buy solar power, not everyone that can build decentralized solar systems. So we need the central grid system also to be functioning.
Okay, thank you very much. Samuel Ezinaya, please could you quickly, briefly and concisely ask your question?
Yes, thank you so much. My question is, why Germany? I mean, considering the framework and the structure of Germany versus Nigeria, I'm looking at the distance between the setup of these two different systems. So why Germany? I mean, the rationale behind you picking Germany as a benchmark for Nigeria and not South Africa, where you reside.
Yeah, thank you very much. Because the reason why I picked Germany is a very well-developed country, and then I actually studied them a little bit, even some of the research I've been doing, and then I look at it that it would be best for us to look at how those who are already developed manage their energy system. South Africa is still also, yeah, South Africa is, I can't call it South Africa to the developed country because they are still developing and they have their own challenges. So they have a lot of challenges regarding their own grid system, also regarding their energy systems. So, and I look around, I see that even most of the things that South African people and the South African government are actually implementing in the energy sectors here, actually from a template from Germany. And that is why I say, oh, Germany should be a reference point because there is a lot of things they have done. I've been there, I've seen a lot, and I've learned a lot. A lot of experts have come to South Africa to give lectures or to train people, and also then a lot of South African people also have actually tried to learn from Germany. So we also can learn from Germany how they are actually developing their countries, how they manage their energy systems, and how they are able to develop to the level they have.
Okay, thank you. Is Germany system centralized?
Currently, Germany system is a mix. They have mixed systems. So that's what I'm telling you now that there is a lot of decentralized systems now that actually come together. So they have a central system, but they have also decentralized system. They both have central system and decentralized system. So the centralized system actually also the people actually build different power plants, and also even government also go into decentralized renewable energy, like I mentioned before. And then there is a centralized grid infrastructures that bring these things together, and then there is a management within that system. Yeah.
Thank you very much.
Thank you.
Yes. So we'll be going to the next question. I think number 2 person. I did not see your hand. I know number Stephen Honora. You can ask your question.
Okay, thank you very much, Engineer Abiola. I want to ask, can you compare unit price of production of electricity from solar and that of gas? Price of 1 unit of electricity from solar and 1 unit of electricity from gas. Now, when you do the comparison, now I want you to advise now or come up with a proposal whether Nigeria, with the rich gas deposit that we have, to the extent that we flare, even now we flare gas, are you advocating that the best way to go will be solar in place of gas? Or are you going to advocate that we massively develop our gas infrastructure, assuming that the grid infrastructure is also in place, that we concentrate on gas generation as against the much touted solar penetration and all of that. Thank you very much.
Yeah, thank you very much. I understand the place you are going. When we have to look at the comparison between the solar and the gas, the truth is the gas has more power than when we look at the comparison more than the solar. But if you have to answer your question, looking at like what you say, if we have the grid infrastructure in place, I would definitely advocate for renewable energy. And this is the reason why, because we know that gas has its own technicality. A bit. I'm actually working on biogas currently. One of the things I know a lot of things about gas, and also even currently I'm working on also a gas in Nigeria relating to Nigeria too. So, but one thing, like I was saying, is that if we have infrastructure in place, I will still advocate for renewable energy. I will still advocate for solar, and then I would advocate for wind and other renewable energy, biomass, and etc. Because I know that definitely there is a great infrastructure that can take those things, and then we're also contributing to reducing the carbon emission, and then contributing to clean atmospheres and etc. But if with the current situation that we are in, here we have issue with poor infrastructure of our grid, then I will suggest that we should use our gas because it is profitable for us to sell our gas, to use our gas at the moment, and then to develop ourselves. So the gas available now, the painful part is that nothing is being used, nothing is being done. So they rather flare the gas than using it for anything. So why are we flaring? We have these resources. They produce this gas daily, every day, and they flare it daily, every day. So why not make use of that gas now that we have issues, and then use whatever the money or whatever that we get from it, build the challenges that we are facing, have that adequate challenge, and then we can now talk about transition. I don't know if I'm able to answer your question. Thank you.
Yeah, you didn't straightforward answer the question of pricing. Which one is cheaper?
Yeah.
Forget about the advantages, other advantages. Which one is cheaper?
Thank you. Based on the current, how do I put it now? Based on the current experience that I have, solar PV rather than gas. Gas is gas is when we talk about gas, it's very expensive. I don't know if I'm communicating with you now. If I'm answering, it's expensive.
Sorry, I didn't hear that. I didn't hear that. You said
Yeah,
solar
gas
is
is more.
cheaper.
Gas, yeah, solar is cheaper to go with. Yeah.
Okay. Okay.
Yeah.
I think I
Yeah.
have my opinion differ anyway, but
Okay. Yeah.
my
Solar is cheaper
opinion is
than
like,
gas. Yeah.
especially in Nigerian context, gas is cheaper in Nigerian context. That's my opinion. Maybe I'm wrong. Thank you.
Okay, thank you very much, Stephen Honora. So we just have a few minutes to take a few questions. Engineer Adeyemi, will you want to have your questions? Please be just one sentence, and that's all.
Mine is not kind of a question. I just want to buttress what Engineer Kehinde is saying to answer our last question about the unit price of a solar system compared to unit price of electricity from gas systems. When it comes to gas systems, we have to look at operational expenditures that we have to be incurring from time to time on our system, and these costs, makes it on the long term to be higher when you compare it to solar systems. And for the renewable system, you're looking at a capital expenditure that you have to incur when you are getting the systems. So once you have a system in place, we are talking about zero margin maintenance costs on our systems. So imagine, sir, if you have a 3 megawatt gas engine in Nigeria that you have to install with a fire system in place, with the house to house this engine, with the control panels, with transmission line, everything to complete, because I was involved in a 12 megawatt CNG power plant in Ibejuleki in Lagos before I left Nigeria, and I know how much it costed us. And then if you compare it to the capital and the expenditure to install a 12 megawatt solar infrastructure, it is just the capital cost to get the system is going to be high at start, but on the longer run, the unit price will be cheaper than that of a gas system. Thank you, sir.
Yeah. Okay, thank you very much, Engineer Adeyemi, for that contribution. Engineer Kingsley, please just let's be brief. We are out of time for questions and answers. I'm not sure if I'll be able to take all questions and answers today, but we can. So I will just be taking the last two questions, and then there's one question in the chat that I want to ask, but that I would pose to Engineer Olorunfemi at the end of this question and answer segment. Engineer Kingsley, do you want to quickly ask your question? Engineer Kentley, are you there? Okay, if you're not there, we would move to Engineer Godwin.
Okay, thank you so much, our presenter, for your nice presentation. So my question will be, what is the role of market in the Nigeria energy system? Like when you compare it to Germany, we have a lot of market. We have the day-ahead, intraday, FCR. Do you think these kind of things are important? Do you think, I never heard you mention it. Is it about building infrastructure? What is the role of market? And how do you think this can affect the transition of Nigeria power or energy system? Thank you. Sorry, did you hear me?
Yes, we heard you, yes. Yes.
Okay. Just that I can't hear anyone, it's just silent.
Engineer Kehinde is, I think, maybe having some.
Because I knew what was happening.
Hello?
Hello, maybe I think maybe his network is not good again, but he's unmuted currently, so I'm not sure. Okay, maybe I take the last question before Engineer Kendi comes back to the question he wanted to ask, which would be I would direct the question to Engineer Olorunfemi in the house. So this is a question. So from Mubarak. Engineer Olorunfemi, are you there, sir?
Yes, please.
Yes, sir. Thank you very much, sir. So the question is, does NSE really have a say in policy change in Nigeria, especially the political sector, or is it always political as usual?
Thank you very much. Yes, mind you, NSE is a professional body that does not have the backing of law. What do I mean? It is not a body can say something and it must be mandatorily taken. However, it's a prior group that uses goodwill, connection, and sound arguments to make contributions. If you study the history of Nigeria, NSE has been very instrumental even in the 60s, all through the Civil War, policy input. As to whether government will take your input or not, whether you are NSE or you are a moderator, Oluwatomisin, or you are Ferdinand, it's not mandatory. That's the challenge. But as to whether NSE has a role, yes, Ever since the first conference in 1961 to date, all our communique and things like this are transmitted to the government, and sometimes they even contact us. But as to whether they implement it to the letter is a political decision. Yes, we have a role to play. Like what you're doing is quite good, is commendable, and it would be nice for the branch and post branch to transmit the outcome, the resolutions, whatever name is called, to the national body, which will collate and transfer to government. For instance, the communique for about the conference, the 2025 conference, was formally transmitted to government. Sometimes they do take some of the points, but the point to note is that it then behoves on us also join politics in one form or the other, so that we can push some of these things. You will realize that those where you have engineers and they are what we call NSE men, those who have interest like the way all of you are doing, they are quick to take these suggestions on board. I hope that's clear.
So that's very clear.
Thank you
Okay.
very much.
Thank you very much, sir, for that input. We really appreciate it. So I hope your question is answered, Mubarak. Engineer Kehinde, are you still on board, sir?
Can you hear me now?
Yes, we can hear you now.
Okay. Sorry for that. I think it's the network. So just to quickly answer that questions, I think Nigerian also can learn on in terms of the business, what in terms of the market, sorry, opportunities that Germany is creating for renewable energy, for renewable energy in their country. So I will mention, for example, the feed-in tariff, which actually created a room environment. I've mentioned that during my presentations. So I think that kind of avenue creates a kind of that kind of policies create a good environment for people to come into business, to do business, or to come into renewable energy business venture. So Nigeria also can also, if we have a policy, something policy like that in place in Nigeria that can encourage people to venture into renewable energy, they know that okay, there is a government backing me, that is kind of incentive that is actually being created, that okay, if you generate so amount of megawatt or so amount, that is kind of incentive that will be all in terms of, maybe the incentive might be in terms of maybe tax free or some other intensive, that will actually encourage people to build or to venture or to do business in renewable energy. I think we can do that. I think government can do that. And then we, how do I put it now? So the example that I gave that the Germany people are using, we can also, if it is possible, it's possible we can implement that. But the issue is, will our government be able to to do that? So, but I mean, we can copy that and also do that for our development. Yeah, thank you.
Okay, thank you very much, sir, for the contributions. I'll be handing over now. I think we need to first of all stop recording. We'd like to take a picture at this point in time. Thank you, everyone, for your questions. For those whose questions were not answered, please, you can drop them in the group. We have a WhatsApp group. Your questions can be forwarded to Engineer Abiola, and he would take those questions there. So for now, we need to take a group photograph. Engineer Adeyemi, are you ready? So if you can turn on your cameras just for a few seconds, and then we take the camera, the picture. So at the count of one, a count of two, Engineer Adeyemi, are you ready? Okay, 1, 2.
Yeah, it's done.
Okay, thank you very much. Yes, sir. So I will be handing over now to Engineer Ferdinand. Yeah, thank you very much.
Okay, thank you so much. Please, can you share